Assalamualaikum and hello everyone. Welcome to our video presentation. Today, our team will be diving into the fascinating world of alcohol. Before we begin, let me introduce our team members. My name is Fatima Azahara, and two of my teammates is Umul Aiman Sarah and Alia Maisarah. I will be kicking off our presentation by taking you through the introduction and the foundational concept of alcohol.
To start off, what exactly are alcohols in the realms of chemistry? In organic chemistry, alcohols represent one of the most widespread and functionally diverse classes of organic compounds that we study. When we look at their chemical diversity, they are characterized by high volatility and a distinct, powerful ability to form intermolecular hydrogen bonds. This specific chemical behavior has a foundational impact on their physical properties. Because of this hydrogen bond, alcohol have significantly higher boiling points compared to hydrocarbons of similar molecular weights. This unique characteristic is exactly what makes them absolutely indispensable, both in industrial chemistry and in our daily application. Now, let us break down the basic concept and structural economy of an alcohol into three pillars. First, we look at the structural backbone. An alcohol is an organic compound defined by its functional hydroxyl group, which is our OH group. What makes a molecule an alcohol is this OH group is covalently bonded directly to a carbon atom within the alkyl group. Because of this hydrocarbon chain can vary in length and size, we use the universal shorthand letter R to represent this variable carbon backbone. Second, we can understand this using a simple water analogy. Structurally, alcohols are organic derivatives of water, or H2O. If you picture a standard water molecule and replace just one of its hydrogen atoms with an organic carbon chain, you transition from inorganic water into an organic alcohol. This structural relationship explains a lot about their polarity and chemical behavior. Third, we bring it all together with the general formula. This molecular framework is universally represented by the arrangement ROH. Whether we look at a simple molecule like ethanol or more complex structure of functional OH group is always the core identifier. Now I will pass our presentation to my next teammate, which is Umul.
Alcohol can be classified into three parts, which is primary, secondary, and tertiary. For primary alcohol, carbon which carries OH group is attached to one alkyl group. For example, is ethanol. Therefore, primary alcohols are easily oxidized to aldehyde and then to the carboxylic acids. Then for secondary alcohol, carbon with OH group is attached directly to two alkyl groups. Therefore, propane-2-ol is classified as secondary alcohol because it can oxidize to form ketones. Lastly, tertiary alcohol is the carbon atom holding the OH group is attached directly to three alkyl groups. For example, is 2-methylpropane-2-O. Therefore, tertiary alcohol are generally resistant to oxidation because the carbon bearing the OH group has no hydrogen atom attached to it. Now we move to the properties of alcohol. The first properties of alcohol are alcohol contain a hydroxyl group OH, where alcohols are organic compounds in which a hydroxyl group is attached to the carbon atom of an alkyl or substitute alkyl group. Secondly, alcohol is a polar molecule which the oxygen atom is more electronegative than carbon and hydrogen, causing the carbon-oxygen bond and oxygen-hydrogen bonds to be polarized. As a result, oxygen is an electron rich, while the carbon and hydrogen atoms attached to it are electron deficient, or we simply call as electrophilic. Thirdly, alcohol classified as stronger acid than alkanes and ether because alcohol can donate a proton H+ from the hydroxyl group, making them much more acidic than alkanes and ethers, although they are still considered as weak acid. Lastly, alcohol has the ability to undergo different reactions due to the polarized bond that allow alcohols to undergo reaction involving breaking of the oxygen-hydrogen bond or acid-base reaction and breaking of the carbon-oxygen bond or substitution reactions.
Now I will explain the uses of alcohol. First, alcohol are used as solvents. They can dissolve many types of substance, including both polar and non-polar. Because of this, they are widely used in pharmaceutical, cosmetics, and also in laboratory experiments. Next, alcohol can be used as fuels. Methanol and ethanol can burn to produce energy. When they burn, they form carbon dioxide and water. Ethanol is also mixed with petrol, which is called gasohol, to make fuel more efficient. Lastly, alcohols are used as chemical intermediates. This means they help produce other important chemicals like aldehydes, ketones, esters, and acids. These chemicals are used to make plastics, medicine, and other products. For example, methanol is an important raw material in industry. So, overall, alcohols are very useful in many areas, such as industry, energy, and chemical production. Alcohols are one of the most significant types of organic compounds with hydroxyl group attached to it. They can be classified into three types of alcohol, which is primary, secondary, and tertiary, depending on their molecular structure of the alcohols. These distinctive characteristics of alcohols make them suitable for use in various fields like solvent, fuels, and intermediates of chemicals.
And now we are at the end of our video. Thank you for watching.